My name is David Golden. I probably saw most of you, or you saw me up on the stage during the opening keynotes. I'm still David Golden. I work for Mongodb and have for a little over a year, and I lead the Mongodb Perl Driver project. So today, this talk is going to be a lot about Perl, as you might expect. It's also going to be a lot about MongoDB. I wanted to stop and see if I need to explain what MongoDB is. So who here is a MongoDB expert, self-assessed? Okay, no experts, that's fine. I should probably raise my hand. I should be an expert. How many people have used MongoDB at all? Okay, a bunch of hands. How many people at least know what MongoDB is? Okay. How many people have no idea what I'm talking about whatsoever? Okay. Couple hands. All right. So I'll go over the next a little bit faster. I won't spend a lot of time trying to explain that MongoDB is for startups that want to be enterprises and enterprises that want to be startups. I'm not really sure what that means, but that's why I'm in engineering and not marketing. Some people might say that MongoDB is a NoSQL database. I won't say that because it's not really NoSQL. And once again, the marketing people would have my head if I said that it was SQL. So if I say that it's NoSQL, that's a no-no. So MongoDB is a lot about storing documents and has auto-sharding and native replication and blah, 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 blah. And a lot of other features, most of which aren't really important because just the top few are enough to sort of get most of the jokes in the presentation. And there are going to be some because some people have a very different opinion about MongoDB. I have to thank Matt Trout for sending this to me a couple days ago, and as soon as I saw it, I said, aha, that has to go into the presentation. And it turns out to be a very good segue to the something else we'll be talking about a lot today, which is trolls, because there are definitely a lot of them when we talk about Perl and MongoDB. And of course, as promised in the title, we'll talk a bit about chainsaws. In my opinion, every talk is a lot more interesting and exciting if there's something dangerous going on. So I will have some live demonstrations. And bizarrely, when I found this, I thought, my gosh, that actually looks a little bit like me. But I realized that I can explain to everybody that it's not me, and you can tell because I would never do something as crazy and dangerous as trying to juggle a hatchet. So that's a good segue to my reminder to do a little bit of a live demo. I'm going to kick off a process that's going to run on my laptop while I give the talk, hopefully not lag Keynote too much, and it will store some data into MongoDB, and then I'll analyze it a little bit later in the talk. So if I can get to the right screens, you've got the right screen. Let me see if I can rig this up again. So this program fires up a RAM disk to store a lot of untarred tarballs and gathers up a lot of information about cpan distributions. And we'll leave this running in the background, and hopefully if it doesn't lag, I'll let it run, and we will come back to this a little bit later on. All right, and we're back. So if there's one kind of takeaway I'd like you to have from this talk, it's that Perl and MongoDB are surprisingly similar. And the first area I'll talk about actually kind of goes back to the trolls, and it's talking about stereotypes. So stereotypes being widely held, fixed, oversimplified views of something. And as we know, trolls love stereotypes. And trolls seem to have a particular love for MongoDB and Perl. But it's a particular kind of love because they seem to love doing something. And what they seem to love doing is shitting all over MongoDB and Perl and making a lot of comments about it that we in the Perl community and people in the MongoDB community don't always take well. But because these things are also kind of humorous and they're also a little bit based in reality, I thought it would be fun to play a little game I'm calling Guess the Meme. So on the next few slides, I'm going to put up a phrase. And there's the subject of the phrase is an underline, and you get to shout out Perl or MongoDB depending on which one you think it applies. So feel free to shout out when I put up the slide. So blank is dead. Perl, okay. We have may well be dead. Maybe JavaScript soon, I don't know. So yeah, there's a common misconception or popular sort of phrase that Stephen Little sort of popularized with his talk a while ago about Perl being dead. So another one, if you know MongoDB, you may have heard blank is web scale. MongoDB. All right, so this was a very humorous video that I don't know if it's even available anymore, but essentially it was a big riff on why people should use MongoDB because it's so fast, and somebody saying, well, really, if you could be even faster if you could just pipe everything to dev null, and the person said, really, if I would absolutely use dev null if that was faster. It was pretty good. And amusingly, just last week at MongoDB World, a whole bunch of T-shirts were printed up with this character on them and sort of distributed out as like sort of secret swag to people. So it was sort of internally, it was kind of adopted as a badge of pride. I don't know. Subvert the meme. Blank is line noise. Perl. All right. And interestingly, we actually saw this very same image with different color scheme last night during the keynote, which I thought was a good example of why people very immediately think of very long, complicated, hard to read expressions as being very Perlish, particularly ones that are kind of artistic. But blank will lose your data. MongoDB, okay. And so, yeah, there's the conception, particularly from the older days of MongoDB when there were some significant bugs, that you put your data in and you wonder why it comes dripping out and you can't find it, which then led to a follow-up joke about, well, you don't want to just have one place to keep your data, you really need 3 because that will solve your problem. Blank is read-only. Perl, right, so there's a sense of Perl's unmaintainable, that it's spaghetti, that you can't possibly read it, and to some extent, Perl is still being judged, I think, by Matt's script archive from the 90s. Blank is unsafe by default. All right, this is actually a trick question, because it's Perl and MongoDB, both of them. So MongoDB, for a while, didn't have journaling, didn't acknowledge writes, and was pretty unsafe by default. But at the top of almost every Perl script you would find by anybody who knows what they're doing with Perl, you'll still find use strict, use warnings, or maybe if you can use a more recent version of Perl, use v5 dot, whichever one it was that makes that turn on strict. So Perl is actually unsafe by default as well. I mean, people get themselves into a lot of trouble when they don't make it safe. So both Perl and MongoDB get a lot of grief from haters. So they're similar in that way. But the other way they're similar is they have a similar data model. I went looking for some sort of picture to symbolize like hashes, which we use a lot. And I thought about, oh, well, do I do the dots and the boxes and the arrows? And I said, well, let me try to find something more interesting. This was the best I came up with, which if anybody's been to the diner restaurant here, the coffee shop, they have hash browns. So we use a lot of hashes in Perl, and we also use a lot of arrays. And while these are all identical, Perl, of course, lets you store heterogeneous data in the arrays. But the idea is we have long, long lines of stuff, and that's a lot of what we work with. Has anybody ever read Perl Doc, Perl DSC? All right, some people. All right, well, that's the data structures cookbook, and it explains all about hashes of hashes, arrays of hashes, hashes of arrays, arrays of arrays, and all these different combinations, which then led me to sort of think about a little joke. Anybody seen Die Hard, know the reference? Now I have a machine gun, ho, ho, ho. So I think John McClane, when he wasn't stopping bad guys, must have been a Perl hacker in his spare time. So Perl programmers use dynamic data structures a lot. It's like the bread and butter of all of our programs, right? Like almost everything we do, objects, they're data structures. It's the stuff we store on them, data structures. Passing data around in a web application to a template, it's another hash. We love our data structures, and so does MongoDB. MongoDB is also built around the same model of nested data structures. So I'm going to give an example using the tick. How many people know the tick? Excellent, lots of people. Spoon. So let's imagine that we're putting together a database of characters from the tick. And so we have a data structure with a name, a battle cry, and a fictional birthday that happens to be my own, and various relations. And so relations becomes a nested set of hashes. So we have relations, and within relations we have friends and we have foes. And each of those are an array. So we have a hash of array as our data structure. What if we wanted to do something completely ridiculous, like let's sort the heroes by the first friend's name? I don't know why you would want to do this, but I had the tick examples and didn't want to retype a bunch of data, so we'll use it. So in this case, we want to sort by Arthur, right? And for any one of these data structures, we want to pick out that first friend's name and sort the heroes based on the first friend's name for some inexplicable business reason. Well, in Perl, if you know what you're doing about sorting, you'd probably use a Schwartzian transform. You'd use a map sort map structure. In the bottom map, you'd pull out the field of interest and cache it along with the original object. You'd sort based on that field, and then you'd have your top map to sort of get you back your original data structure. And that would be a way of sort of sorting on a deeply nested field. In MongoDB, it's a different approach, but it's sort of similar in concept. So you do a query, you sort of find. The empty document means just give me everything, match everything. And then you give it a sort clause, which in this case is relations.friends.0, which means go down into that data structure and pick out the first element of the friends array. And then the one means sort it ascending rather than descending. So these two are actually really similar. Both of them look at the data structure as a nested structure and let you work with it, preserving that same correspondence of nesting all the way down. So it makes it very easy to sort of go back and forth between the two. Yes. The clause on the bottom is how you would do this with the MongoDB driver. So I've left out all of the parts about how you would actually set up the MongoDB driver. But this would be, heroes would be a MongoDB collection object, and you call the find method on it, and then the rest of that gets passed on through to the database. MongoDB uses as its query language essentially documents. So if you think about like a JSON document, that is how you pass in a query, and that's how you pass in extra information about how you want to sort of manipulate it. So most of my examples, I think all, unless I've screwed it up, will be examples using the Perl driver, and I'll show a little bit more later. So one of the other things that's very similar is that both Perl and MongoDB are missing things that others take for granted. So for example, Perl has no function signatures. Okay, we do, but they're experimental, and maybe they'll be non-experimental at some point, and you probably can't use them in production until some period of time when you've moved to that version of Perl, and most of CPM won't use function signatures for another 10 or 15 years. So there's no real function signatures. MongoDB has no read committed mode. You can't actually make sure that the data you're reading has actually been committed out to all of the other replica sets in a distributed system. And okay, yeah, that's coming, and it'll be there in MongoDB 3.2 later this year, but it's not there now, so you can't use it in production. Perl doesn't have concurrency, or at least not any real concurrency. You can fork off processes and do various other tricks. Perl threads don't share any memory. Perl threads are an abomination that have essentially been discouraged in 5.22 anyway. MongoDB has no transactions. Perl has no real object-oriented programming. You can associate methods with structures in namespaces, and that's it. And everything else is you have to go build yourself. Which, at least to our credit, we've built some pretty cool stuff with Moose. So maybe not having some of these primitives have let us do some more interesting things. MongoDB doesn't have joins. Everything operates at the single document level. Again, footnote, some of that may be coming left outer joins in 3.2 later on. That was just announced last week. Perl doesn't have Booleans, which doesn't seem like a big deal, but if you think all the times you're having to figure out, well, is it 1, is it 0, is it an empty string? What does 0 but true mean? Lots of cases where the lack of a real Boolean has been a problem. And as we see in Perl 6 starts adding back in all these types because the realization was, hey, they're actually useful. MongoDB doesn't have any stored procedures. Everything has to happen client side. Nothing gets put on the server to sort of be able to execute in a consistent way. But of course, we're Perl, so experienced users work around flaws, and the same is true for MongoDB. MongoDB doesn't have sort of idempotent writes, or you can very easily have non-idempotent writes. I want to increment a field in this document, and what if there's a network error? I can't send that increment again, or it might happen twice. I don't know, maybe not. And you can work around it with two-phase commits and other sorts of approaches. Perl has strings for errors, which is a horrible way to pass error information around, and so we've worked up things with exception objects, and then when you catch an exception, you don't know if it's a string or an exception object, so you have to test all this stuff, gobbledygook. Again, like read committed, MongoDB doesn't have a consensus read. You can't actually make sure that all the nodes necessarily agree if there isn't a partition, but you can sort of fake it with a write, so you sort of do a write that's sort of do a write and atomically give me back the result, and you have something that works pretty well. Perl version numbers are a complete mess. Some of you know me and know that this is a particular frustration of mine. Those of you who don't know why this is a particular frustration of mine, you can Google the phrase, version numbers should be boring, and you'll get my article, which is kind of I think still the definitive post on the subject. MongoDB has a query language, which isn't really a language, it's a bunch of data structures. So if you think about expressing all of the logic you want for a query, not in some sort of programming language style, but expressing it essentially as an abstract syntax tree in JSON, that's essentially what you have to do to express certain queries. Makes it a little cumbersome. And I'll show you some of that later on, I think, in some of the live demo. Perl has ambiguous scalar types, which as somebody doing database work and anybody who's had to work with interoperating with other languages with things like YAML or JSON or message pack or anything else, this is really hard because you often don't know whether something is a number or a string. Is a zip code a string? 08544 New Jersey, is that a number? String? I don't know. Is a social security number a number or a string? I don't know. And in Perl, you don't actually know it, and if you actually try to use any sort of deep introspection to see, is this thing really a number or a string down at like the innards of like the XS level, it actually depends on whether it's ever been used in a string or numeric context. So if you have a number, 1, 2, 3, 4, 5, and you say, okay, I want to verify that that's really a number. Does it match the regular expression, \d plus with the appropriate anchors on each side? Well, now you've just used this number in a string context. So now this scalar is both a number and a string. And now if you try to serialize it, what happens is implementation defined. Oops. And so we can work around it by coercing them, 0 plus your thing every time you want to save it, and things like that, but it's ugly. MongoDB has a 16 megabyte document limit. If your data doesn't fit into 16 megabytes, tough, figure it out. Perl IO layers are sort of a complete mess. If you've ever tried to like copy IO layers from one handle to another or save IO layers for a handle then put them back on later, total mess. MongoDB rolls back your data on a failover, possibly. So maybe the data that you thought you wrote just went away and you don't necessarily find out. Oh well, figure out a way to work around that. On the positive side, however, we have vibrant, enthusiastic communities. Both MongoDB and Perl have user groups. Mugs, they're called for MongoDB, Perl mongers. Both have conferences, mailing lists, IRC, all the sort of usual stuff you would find in an open source product. MongoDB is an open source company, so the vast majority of what they do, all the database itself, all the drivers are all open source. There's a small sliver of stuff that's enterprise only for paying customers, most around security and LDAP and some things like that. But it's an open source company, so it wants to have a big, vibrant community. And the reason that I think that it does is I think that Perl and MongoDB have very similar philosophies. And particularly, I mean, both of them are focused on these two terms that Larry came up with, manipulexity and whip-uptitude. So manipulexity, Larry defined as the manipulation of complex things, being able to do not just simple things, but do complex things. And whip-uptitude was the aptitude for whipping things up. And Perl was really inspired by his idea of a language which would give you both, whereas he thought C was great for manipulexity, and Shell was really good for whip-uptitude, and there wasn't anything that gave you both, so he invented Perl. And the idea behind these two is that both are tools for getting the job done. That both are things that are designed to let you get the job done and get on with your life or get on with the other 25 things you have to get done that day. It's designed to do things and get out of the way. And so sometimes we think about a language like Perl as a Swiss Army knife, but this wasn't hyperbolic enough, so oftentimes you'll heard it said that Perl is a Swiss Army chainsaw. Heard that expression, Swiss Army chainsaw? Okay, most of the room. Well, I got really curious about where this came from, and so I did some searching around, and I found it in the jargon file, a little bit of a history. And this, I've got a couple long excerpts, but I think they're kind of insightful. So there was a hacker by the name of Henry Spencer, who apparently was well known at the time the jargon file was written, but not to me. And he described Perl as a Swiss Army chainsaw for it being exceedingly powerful, but ugly and noisy and prone to belch noxious fumes. And the jargon file then goes on to editorialize that this had two results. One, that Perl people adopted that as a badge of pride, and then it also became a general term to describe anything highly versatile but distressingly inelegant. And I thought that was a really interesting phrase, about highly versatile but distressingly inelegant. Does that apply to Perl? Does that apply to MongoDB? Yes. I think absolutely it kind of captures the power of both. Both are great at a few things. And they're good enough for many things. And they're sort of the reason that people get a lot done with Perl, and the reason I think people like MongoDB a lot, is that it lets them do a lot of things with a relatively small toolbox. You don't need to have a lot of stuff there. Each tool lets you do a lot of things, even if it wasn't necessarily designed for it. So if having one of them is good, wouldn't two of them be better? The MongoDB Swiss Army chainsaw and the Perl Swiss Army chainsaw. Which then leads me to time for actually getting back to the live demonstration. So I'm going to find out if, in fact, this is finished. But I'll explain. I don't hear the fan, so it may actually be finished. That's a good sign. Or it's died, and then we'll see what happens. So this demonstration is sort of based on CPAN metafile indexing, which was a problem that I had when I was in Berlin for the QA hackathon this year. As I talked about in the keynote, we're trying to find out how many things depend on other things, how far upriver or downriver is something. And I wanted to do some analysis, and I happened to have a mini CPAN on my laptop. So I had a copy of sort of the sliver of current stable modules on CPAN, about 30,000 or so tarballs. And I said, okay, great, I've got this locally. I should do something with it and analyze it. So, well, most of these, or at least most of the recent ones, should have a meta file, a meta.yaml, a meta.json file that describes some of the dependencies. If anybody was at Matt Trout's talk yesterday, I think it was, he talked about the reasons why it's only an approximation of dependencies, because meta.yaml or meta.json is pre-configuration. So I knew it was an approximation, but it was sort of quick and easy, and it was there and let me get the job done. So a meta.json.file is created by module build or XGTils makemaker or module install or module build tiny, whatever you're using to ship your tarball, and it describes things about the distribution. So I have a, here we go. I have an example of sort of an excerpt from a meta.json file. So there's like an abstract, has one or more authors associated with it, has prerequisites, which are themselves a sort of a nested data structure relating to sort of the phase, like runtime or configure or test or build, and then is it requires or recommends or something else in the specific modules and the specific versions that are required. There's a provide stanza, which is optional, but sort of says, here's the module and here's what file it's in and here's what version it is. Has a release status, is it stable or unstable? People extend these with X underscore fields. So a very popular one is X underscore contributors. So you go and you scrape out of your Git commit logs all of the list of people that have ever put a commit in, and you stick it in a big array, and then MetaCPAN displays it on the right-hand side of, here are people that have contributed. And it's a way of thanking people for their contributions and being a little more public about it. So what I wanted to do was grab out of these 30,000 or so distributions, all of these meta.yaml or meta.json files, if they existed, shove them into the database and do some analysis. So here's my reminder to jump to that. Any questions so far while I get the terminal up? All right, so the question was whether we have to define a structure ahead of time, and no, and the answer is no, and that's one of the powerful things about MongoDB is that it has a, I think the official term I'm supposed to use is a flexible schema. The reality is that there's really no schema, that any document can go in, and that's particularly nice if you have a collection, which is sort of the MongoDB equivalent of a table with, let's say, 1 billion records, and you suddenly decide you want to start adding some fields. You don't have to go back to the other 1 billion records and add those fields to those. You just add the field to the new documents that you insert. And a meta file, they're all very different. Some of the fields are optional. Provides is optional. Some fields are required, but not everybody actually puts in all the required fields. So every single meta document is completely different, even though they'll mostly have the same fields. Sometimes they'll have, some will have X contributors and some won't. And so one of the advantages of using MongoDB, I thought, was I can just take all these files, throw them in, and not have to worry about what's actually there. All right, so it seems to have run. There were 307 blocks, so this was about 100 tarballs per block, running in parallel across 10 processes, which pretty much maxes out my processor, but still let me run Keynote, so that was cool. And the whole thing ran in about 9 minutes. It ran in 9 minutes because Rick and I had a friendly competition in Berlin to try to see who could make it go faster, because our first attempts would take like an hour. And we said, well, let's make it parallel. Hey, let's figure out. And so we kept refining how fast we could make these things go. And when we were on the airplane coming back from Berlin, we kept like walking up and down the aisle, talking about how fast we had made it go until Rick set up a bootleg IRC network on the plane's Wi-Fi. No, it wasn't even the plane's Wi-Fi. He set up his own laptop in infrastructure mode. We all connected and we talked over IRC from our different seats. I'm sure there was some FAA issue there, but hey, it worked. So now this thing was able to run fast enough that I could actually do it live during a talk. So I'm going to walk through the code that was used to do this, and then I'll show some of the results. All right, so this is the program that ran, and the way I've structured this program just for the presentation is I've put sort of a worker subroutine up top that really is sort of the guts of getting a meta YAML file or meta JSON file, putting it into the database. And further down below is all the stuff about how it parallelizes and chunks this up. I'm not going to cover that, but if people are curious, after this is over, I'll sort of post some information about where the code is if people want to troll through it. Or you can grab me at a break and I'll walk people through it. So the start of this, we have a whole bunch of modules that we load. That's great. And then we get down to this worker function. And so this worker function winds up being called within each of these sort of forked out processes. And it gets a chunk of data, and chunk of data is a list of up to 100 CPAN distribution tarballs that need to be processed, and just tells us what block we're on for reporting. CPAN path says where on my hard drive to find it, and there's a database name and a collection name for where it all should be stored. And this kind of gets passed in from the parallel fork manager process. So the first thing we do is we make a connection to the database. So we get a Mongo client object, new with no parameters, just connects to localhost at the default port where I have things running. We then get a collection object. So get collection, get database, get collection, and the collection object is the thing you work with most often for inserting, deleting, searching, etc. And because I know I'm going to be inserting a whole lot of stuff, I don't want to insert them and do a database round trip on each one. So I set up a batch object, which will just sort of accumulate all the inserts. And then when I'm done accumulating inserts for the whole chunk, it gets executed in one shot. I actually sort of process the chunk using a CPAN visitor, which is a module for walking through a CPAN on a disk and untarring each tarball and letting you do something inside it, mostly callback driven. So it gets the CPAN path, it's told to be quiet, or actually I turned quiet off because I actually wanted to see errors from the tarball unpacking. Knows which files to run, and you can use a stash to sort of customize stuff. Prefer bin means use a system tar, not pure Perl tar, which was another one of those optimizations we figured out in Berlin to make things go much faster. And then the iterator method is what then starts to go through each of the distributions in the chunk. There's a check callback, which just makes sure that the file actually still exists, in case my mirror has updated in the background and made it go away. And then the visit callback is the thing that actually does the work. So it gets the job variable, which just has information about the work to be done. The first thing we do is we unpack the path. The dist path is like da-golden/pathtiny-0.00 whatever .tar.gz. Into a CPAN distname info object, which essentially parses the file name to pull out useful bits of information. This is, I think Graham Barr wrote this for search.cpan.org, and it's sort of the de facto standard for how to parse out an author or tarball path into something useful. So then we set up sort of a basic document that we'll use to insert things in. So the underscore ID is the sort of unique ID primary key for the document. We just set it equal to that dist file, which is, I believe is just the name, like path tiny, and the suffix, and not the author part. So it's sort of close to the distribution plus version plus suffix. The upload date we just grab off of the date of the tarball because the mirroring process actually preserves that, which is kind of nice. And the uploader is the CPAN ID of the person who uploaded it. I put these all in as underscore fields so that it doesn't collide with the fields from Meta when it gets added in later, because underscore is both illegal for Meta and unlikely to be there, so it seemed it would avoid collisions. Could this have been checked a little bit better? Yes, but again, this was sort of quick and dirty work in Berlin. So then we try to find a meta file. Does it even have a meta JSON or a meta YAML? If it doesn't, then we just insert what we've got, and we have a record which says, here's a distribution, and since there's no data, we know it's not there. We record the meta file, whatever it was. We then try to load it with the CPAN meta, And if it succeeds, great. If not, we record what the actual error was, trying to parse it. Maybe it was bad JSON, maybe it was something illegal that couldn't be handled. And so if we didn't actually get a meta object back out, now we just insert the document that has the file name and the error, and we have that record. So if we've gotten that far, if we're here, we have a CPAN meta object, which is the parsed version of the meta JSON or meta YAML. And here I pull out a lot of the prerequisites that are all nested and I flatten them because for the analysis I used, I didn't really care whether something was a runtime requirement or a test requirement. I just wanted all the requirements together. So these things here pull all of it out into an array. We store it in an underscore requires field. And I'll show this during the, when I get around to actually querying the data. So this is just sort of the sorted list of the merged prerequisites. So this is foo bar, foo baz, test more, on out. And then instead of doing any sort of nice merging, I just smash it all back together into the doc and queue it up for insertion. So when this processes through all the chunks, I then try to execute it. If it executes, we get one of these block n inserted messages, and if it fails, it says, oh, it failed, and tells you what was there in the chunk that it failed on. So that was a very fast run through 86 lines of code. Any questions? All right, everybody followed, or everybody doesn't care, or I actually did a good job explaining. I'll take the latter choice. CPAN, I use Parallel Fork Manager. CPAN Visitor by itself could just iterate through an entire CPAN data structure. But the problem is that it basically forks off, if you run it in parallel mode, it'll fork off a process for every tarball to process. And that becomes a problem if you're talking to a database because it means that every process has to connect to the database for every one of those tarballs. So we kind of, what Rick and I figured out was a way to, we inverted that and we ran Parallel Fork Manager first, fork off into up to 10 processes at a time and give them each chunks of 100 files to run through. And so all of that is down here, which I won't really go through, but essentially it gets the collection information, sets up a RAM disk, gets parses an O2 packages to find out what all the disks are that are in the mini CPAN to do. And then Parallel Fork Manager fires up a number of jobs, and then something basically chunks up the jobs, spins them off to Parallel Fork Manager and lets it go, and then eventually finishes. And then there's some stuff to catch interrupts, so it'll clean up the RAM disk. So I didn't want to walk through that in great detail, but it was kind of a clever way to fork out first, then connect to the database to minimize the number of database connections. And it's kind of a trade-off of the smaller the chunk size, you have more database connections, but you're keeping your processor more busy. With larger chunk sizes, we got into situations where, the last 1,000 or so processes are all running on one processor, or the last 1,000 tarballs are all sitting on one processor waiting to go, whereas if you chunk it up into batches of 100, the processor stays a little busy faster. Again, this is all part of our race. So with that going into the database, we can then dig through the results. So reply is a Perl REPL that's kind of nice. I'm in the MongoDB Perl Driver repository, and I've built the latest master up, so I'm going to use that because I like it, if I type things correctly. And I'm not even using the Damien Conway trick of actually like just typing, pretending stuff, and it's all scripted up. I'm actually typing this, so you'll see my typos. Right. Yeah, his talks are like, looks like he's amazing. And it all comes out okay because it's actually all just scripted, but I'm not doing that today. Yeah, he scripts the mistakes. It's really clever. I think the script can automatically make a certain number of typos and backspaces and goes for it. Damien is like the god of presentations. We can only aspire to those heights. All right, so if I did this correctly, I should get a collection object. So MongoDB connect means connect to the local database. NS means give me a collection under the namespace. CPAN is the database name. Meta is the collection name. I get a big thing that gets dumped out. So now let's do a little check. Let's see how many things did we actually record. I don't even need the semicolon. So 3,702 documents were inserted. And then we can start to do some queries because count will take a query structure. So I can count, let's see, all right, so let's, actually first, before I show the count, let me actually just sort of show you what this one of these looks like. So I'll just do find one. Without any parameters, it'll actually just pick off the first document that's in there. I have no idea what that is. So here it is. So this is Pingdom Client. I have no idea what Pingdom Client is, and it's by Dominic Schultz. Is Dominic in the room? If so, you're the lucky winner. So this whole thing has, here's the underscore ID. It's text Pingdom Client 0.13. This was taken out of meta.json, not meta.yaml. Here's the flat requirements list. The upload date is epoch seconds, and then the actual meta file: abstract, author, dynamic config, generated by blah, 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 blah. All the prereqs, deeply nested, resources, no X contributors here, oh well. So that's what the document in the database looks like. But we have these, we can do some searches through this. So I wanted to see how many things depend on path tining. So I can, and this is sort of now where we have this query language, which is really a structure. So I say count, and I say I want the requires field to have path tining. Now remember that underscore requires is an array. So when I'm saying underscore requires path tining, I'm saying find me all documents where path tining is in that array. 324. Now some people like IO all and think it's better than path tining. So let's see how it does against IO all. Only 107. Now, of course, I think IO all is a great scripting tool, so it's probably used a lot off of CPAN. Maybe it's not as big a requirement on CPAN. What about something that's more popular? Moo, 1004. Moose, 2406. Anyone want to suggest a module to see how many things on CPAN require it? I could, but I don't want to take the time to figure all that out right now. DBI, 817. I think partly because DBI tends to get used by end applications that aren't on CPAN. Oh, that's a good one. All right, data dumper and then test more. Okay, data dumper, a little over 1,000. So let's look at test more, which kind of goes back to that CPAN river conversation. Almost 16,000. And this is actually just direct dependence. This is not even like calculate all the deep ones. I actually use this data set, threw it into the CPAN graph module, and let it calculate out all the dependency graph for me. So that's how we do some queries with this. There's also some other interesting things we can do. Let's find out how many times I'm listed in X contributors. So again, X contributors is an array. Comma, by the way, is my Vim shortcut for doing fat comma. If anybody uses Vim, you might like that abbreviation. But then I type it everywhere else, which is a little annoying. So I'm going to do a little interesting thing here. I'm going to do this with a regular expression. So I use DA Golden as my email address on my Git commits. So as my email address is in there, or any other DA Golden is, it should come up. So how many times am I listed in X contributors, or how many distributions? 34. Okay, I've contributed to some. What about Karen Etheridge? People know Ether, Karen Etheridge? Know her by reputation? She contributes to a lot. Oh, look, there's only one. But she spells her name capitalized, and her email address is not Etheridge. So let's make this case insensitive. 173, that's a little more like it. And so this is one of the other things that's kind of nice about the way the MongoDB driver for Perl works, is that you can give it a regular expression. And as long as it's simple enough, essentially following like PCRE rules, it'll get turned into a BSON, binary JSON regular expression type, sent up to the database, and the database says, oh, you give me a regular expression, I'll use that for matching. All pretty much automatic. Very nice and clever. All right, I think that's probably enough of this demo for now. We'll get back to the presentation and sort of talk about a couple other things. Switch handling the clicker on the right. I'm a righty. So this was an example of getting CPAN metafiles loaded up into the MongoDB database, which kind of got me thinking, just as a thought experiment, and partly for the sake of this presentation, what if we wanted to rebuild CPAN? What if we wanted to build CPAN on top of MongoDB? What would we need? Well, we need some way to store tarballs, put them in, take them out. We need to be able to process tarballs when they're uploaded to index them. We need some worker processes. So we might want to collect the logs from a bunch of different worker processes. We'd want to be able to look up modules with an index to find out what distribution they go to. Maybe we want to do text search. Pause doesn't actually do this. Usually we rely on things like search.cpan.org or metacpan.org to find things on the basis of text, but let's use it partly just for an example. So for storage, MongoDB has something called gridfs, which is sort of a convention for how to store files, chunk it up into small pieces and spread it out into a collection, put it in and take it out. So this is an example of storing a file. You open a file handle for reading. You get a gridfs object, and we'll call it here tarballs, and then you call the put method to take whatever is in that file handle and upload it. And then to get it, you can just call the get method, which gives you an object which you can then call slurp on to pull the bytes back out. Now, this running on one computer isn't all that interesting because all I'm doing is taking a file and saving it onto one computer, which I could do with the file system. But MongoDB has the ability to be replicated. So I could have a primary and two secondaries. And if I upload the stuff to the primary, it gets replicated out to the secondary. So if the primary server dies or gets shot or somebody spills coffee on it, we don't lose any of the data because it's been backed up. So we get sort of automatic replication of files. It's kind of a nice feature. So what about workers and processing? A couple years ago, I wrote MongoDB which is a sort of a message queue built on top of MongoDB. So in the supervisor process or the task assigner, you created a MongoDB object. You give it a bunch of parameters for what the database is you want to talk to and your credentials and et cetera, et cetera. And then you can add a task. And a task is just a document. So in this case, tarball ID, and here's an ID, maybe that we just put in gridfs. And then in the worker, they'll have to set up a similar queue object with credentials, which I've left out. And then it can grab a task by calling reserve task. Now it has this document, it can process it. And then when it's done, it can call remove task to sort of take it out. So the task stays in the queue, and then if the worker doesn't respond back to remove it, eventually that reservation expires and some other worker will pick it up, all sort of automatic. So then we have logging, capped collection. Capped collection is basically like a ring buffer. You can insert documents into it. When it fills up, it'll just keep on staying at a maximum size. So we could create it. And then we can use a tailable cursor. So we can use the find command on assuming log is a collection. We use the find command. We give it no search, empty document means find everything and make it tailable. And when it gets to the end of that cursor and there's no more docs to be read, it'll just return nothing. But eventually, if somebody inserts a new document, a worker puts a new log entry in, then the next read will pull it up. So we have a way to do sort of a tailable log distributed across multiple systems. Yeah, the polling time would have to be like you'd set that up in your application for how often you want to poll. There is a way to set up a cursor that will actually wait a couple seconds. You can't actually control it. You can have a tailable await cursor that will block for a second or two to see if anything comes in. So you can cut down your polling time a bit if you're willing to accept a couple seconds of blocking. So we have an index lookup. We talked a lot about the query language. Imagine we had a packages collection that sort of indexed modules to versions to distribution tarballs. Then we could do a query on it. Well, I'm looking for the module foo, and instead of today where like the O2 packages file that CPAN is driven off of is like one module, one version, one distribution, we could have a bunch, which would let us do some interesting queries like, I want foo where the version is greater than or equal to some minimum value and less than or equal to some maximum value. Except we can't, because version numbers in Perl suck. And there are too many ways to show them, and we'd have to normalize, and that would sort of be awful. So we'd have to do it some other way, maybe with these meta files when they're uploaded. We check to see if anything in the provides is authorized. We can note that, we can look up on that, and then sort through versions client side. We have text indices to search, so I want to take that meta collection we have and add an index. That it does a text index on the abstract or keywords fields or other fields, and then we can search on it using a $text operator. And this is where you start to see some of the ugliness of the abstract syntax tree representing queries as documents, but it works. There are some other handy tools, geographic indexing. Maybe we want to record the IP address and use MaxMind's GeoIP database to find out where uploads are coming from or where index requests are coming from or downloads and find out what modules are popular in different parts of the world. I don't know, could do it. Expiring indexes, TTL indexes, if we wanted something to expire after a period of time, maybe we're going to cache some results, put it in an expiring queue, and after a period of time, the database will automatically purge it on out for you. So that kind of is just the wild set of examples of things that you can do with MongoDB in your toolbox. I wanted to talk a little bit about where we're going from here. So coming very soon will be the MongoDB version 1 beta 1 release. This is what I've been working on for most of the last year, sort of almost a total rewrite of the version 0 driver. We've had a number of alphas and we're about ready to do the beta. And when I say coming soon, I really sort of meant like right after this talk. And then I was thinking, well, you know, I might be a little busy, I might go to some other talks, so maybe it'll be before lunch. But definitely during YAPC, I will ship this. And then I had kind of a crazy idea, which was like, maybe I should just ship it right now, in the middle of the talk. What do people think? All right. This all sort of assumes that the Wi-Fi holds up, which I think it has. But I think I have 4 minutes left, so I'm going to give it a shot and see if the test can pass in 4 minutes. So, yeah. All right, so I'll get back over to here. Nope, this is where I want to be. Okay. Park this a second. So of course, because version numbers are awful and I don't actually have real semantic versions, I have to actually sort of use this funny versioning where I asymptotically approach 1. So 0.999.999.1 means the first beta release. The 999.998 was the alpha series. We were up to 999.998.6. So that's what I'm going to do, and then I'm going to say diesel release. People use Distilla. Some people know what Distill is. Distill is a release tool. What this is going to do is build up the tarball, run a whole bunch of tests, run some release tests, prompt me if I want to upload to CPAN, and if all goes well, after a little while, it'll be ready. So I'm going to kick this off and pray. Beginning to build. Okay, it's doing stuff. It's working. It's processing stuff. Let's see if it actually gets there. All right. Checking a bunch of stuff. All right, so I'm going to let this run. And maybe in 3 minutes when the talk is over, I will see if I'm ready to say yes and actually upload. So what's coming in the version 1 upcoming release of the MongoDB driver? Well, better server discovery, monitoring, and failover. Configuration has become immutable. There's no longer any weird globals either that can cause action at a distance. There's new CRUD and index APIs that are now standard across all the different language drivers. So if you see a method call in one driver, it'll basically be the same method call in the other driver, modulo, camel case, or underscore method names. Error handling will be consistent. The old driver used to might throw an exception, might return a Boolean value to tell you if there's an error or not, might return a hash ref if it succeeded, or a string if there was an error, and something else as well. So now everything is all exceptions based, much more consistent. This progress towards a pure Perl option, a lot of the XS and C stuff has been removed, and we've got some hooks to allow it to go pure Perl eventually in the future, and we really improved BSON round tripability. I saw this great cool thing about a car that looked a lot like my first car. So round tripability, the old driver used to have BSON that would come, you could download a document from one collection, upload it into another collection, and the data types would change. Not good. So what I'm asking of you, having sat through this talk, is to try this out. Or if you've tried MongoDB before and it didn't work for you and you didn't like it, please try it again. The MongoDB server has gotten much better since version 1 and version 2. It's now at version 3, significantly more reliable, significantly more features. And I think it's worth giving it another shot. I also ask that you get involved in some way. So like I said, download MongoDB, try it out, try the beta driver as soon as I actually get it shipped. Find a user group, go to some meetings, see what it's all about. You can follow my blog, which is at dagolden.com, or gets covered on the Ironman and other aggregators. Follow me on Twitter. Plus the driver on MetaCPAN. This actually turns out to be weirdly important for me personally, and I'll explain why outside. And ask any questions. All of that would be helpful. If you like it, blog about it, do it yourself. So any questions before I check to see if I can upload? Okay. If there aren't questions now, you can always email me at david@mongodb.com. So with that, in my remaining 26 or so seconds, at least according to my timer, let's see if I actually upload. Do you want to upload, continue the release process? Preparing to release MongoDB v0.999.99.1 trial? Yes. Posting the upload, updating a lot of files, pushing to origin. All right, and it's done. So, some point soon, Meta CPAN will pick this up. Not yet, but soon. So if you check back in about 5 minutes, it'll be available on CPAN to download. Thanks very much.